And welcome everybody to the Daily Space Weather. Today's a great example of how you can see an increase in space weather big time while seeing a dip in solar activity. We'll tell you all about it and lots more today at the Smash News Network, least busted name of news. Thanks for tuning in. Congratulations on realizing the channel exists. We're frankly surprised that you have. In all seriousness, thanks to our new subscribers. You may see some activity in the southeastern limb as well as the northwestern limb. What's going on down in the southeast did indeed involve a modest coronal mass ejection, where the sun blasts material out of its atmosphere into the greater solar system. It's not earthly directed, but we do have two earthly directed CMEs coming. Geomagnetic storm conditions from a coronal hole high-speed stream and lots more to cover. A subsiding solar energetic particle event here is that northwestern limb, where we saw another long-duration M-class flare, which has just subsided when we started producing the video. So if you'd like closer imagery of that, okay. How's that? Is that close enough? What's that? Not close enough. Can we get any closer, Smash staff? Okay, there you go, for all you sticklers. You may call that the money shot. Yeah, the money shot. Now let's take a brief look at that CME that came out of the southeastern limb, since we did indeed stream that. Here it is on the Twitch channel. Great imagery there from the GO 16 SUVI with that wider field of view. And at the same time, a sweet crown prominence up there at the North Polar region. You can expect to see more and more of those over the coming year as we approach solar maximum. So let's just take a brief look at sunspots here and the magnetic fields. Here is September 1st and September 2nd to date. And we've seen a decline in solar activity here. So we've seen degrading sunspots. And we're going to see a reduction in the sunspot number in the next 24 hours unless new sunspots form or rise. So another just to reiterate, a great time to highlight the fact that you don't need to see lots of sunspots or a high radial flux to see major solar activity. So there is the colorized magnetogram from SDO for the past, well, it's yesterday plus today to date. It's more than 24 hours. And let's go over volcanoes. But first, take a moment to press like and subscribe if you enjoy the content. Again, thanks to our new subscribers. As we approach a certain number that I don't find particularly relevant, press that subscribe button. We need people like you to press share and leave comments and so forth, because we do not believe that the algorithm is helpful at all. Like our thumbnails and titles aren't good enough for people to click on. Are you kidding me? Go look at our thumbnails. They are totally sweet. Anyway, these are the volcanoes that are erupting, starting with Abico, which is producing a 13,000-foot ash plume. Unknown volcanic ash plume from Mount Mayon. Please do not pole vault the caldera. Luatolo there, also erupting. No indication on the ash plume size there from Luatolo either. Semeru is exploding on the Isle of East Java. It's producing a flight level 150. That's a 15,000-foot ash plume. 8,000-foot ash plume as Dacono explodes. On Halmahera, Popocatépetl exploding. There's an uptick in central Mexico. Popocatépetl now producing a 30,000-foot plume of volcanic ash. Flight levels 300. Flight level 190 over Guatemala from Santiaguito. Flight level 150 over Fuego in that same country. Revenador exploding. Flight level 150. Not sure about Sabancaya. It is unable to be detected. Probably from things like clouds. Next, looking at seismicity, there was a 6+ magnitude quake. It was at depth, however, we'll get to it. We'll call out quakes of a 5 magnitude or greater. So rolling up the list here. Yesterday started out calm, and then a 5.3 at Papua New Guinea. That one was at depth. That 5.3 occurred at 19:09 Universal Time yesterday evening. And then about an hour and 20 minutes later, a 6.1 hits the Kuril Islands. That was at a depth of 146 kilometers. So no likely tsunamis from either of those quakes with their extreme depths. And that's it. Those are the only 5+ magnitude quakes occurring in the past 24 hours. Now headed back to space, here's the past 24 from SDO 171 angstroms, the house favorite wavelength. And let's zoom in on the equatorial view here. Again, as forecast yesterday, the main activity is up there in the northwestern limb, and there still is certainly a likelihood of major flares up there. So don't expect that to end yet. There is still plenty of time, even after those sunspots have set fully out of view. The 10.7 centimeter radial flux has dropped to levels not seen since mid-May of 2023. So a big downtick here in sunspot number and indeed in the radial flux. So there's that black line you can see. That black line right there, that is the 10.7 centimeter radial flux. And we haven't seen levels this low since around May 15th or so. So a big downtick here in solar activity. And don't expect that lull to continue, as we are not at solar maximum. So anyway, here's the Space Weather Enthusiast dashboard, and guess what? We've moved into geomagnetic storm conditions, mainly just because of a magnetic field shift. There has been a coronal hole high-speed stream showing up, so expecting 2 coronal mass ejection impacts. And I thought they were going to be a little bit later here than NOAA. NOAA's expecting the CME to arrive late tonight on September 2nd. And then there will be a second one showing up late tomorrow. So anyway, 2 CME impacts. We're not expecting the first one to show up until a little bit later here, sometime like late morning, maybe around 12 noon universal time, but we'll have to see what happens. You can expect 2 coronal mass ejection impacts, though, so it could be early morning aurora for mid-latitudes tomorrow, Sunday morning. And if you think you see the aurora, make sure you take out your camera equipment. If you have any idea that you've seen the aurora, make sure that you take imagery of it, because the aurora is mostly in ultraviolet wavelengths. So that's not visible to the naked eye, but your camera picks up more spectra than the naked eye does. So little consumer tip there about the aurora. And here is NASA's forecast. There's that second CME. It's only going to be like a glancing blow, and it may miss entirely, but it does look like part of that coronal mass ejection will strike Earth. So that'll be the second one showing up later in the day tomorrow, Sunday, September 3rd. Here's Earth's magnetic moment from space for the past 4 hours. Again, we have moved into geomagnetic storm conditions, and that will subside the next time it updates, most likely, because we've seen the field shift back into positive BZ territory. We'll show you that here in a minute. Again, that's the last 4 hours of Earth's magnetic moment from space. It depicts magnetohydrodynamic pressure. It's the geospace magnetosphere movies, the past 4 hours. Here are the past 4 hours of Earth's magnetic moment from the ground, and this is a good thing to monitor to determine whether or not you'll be able to see the aurora at your location. So where you see big changes to the Earth's B field there, depicted by that red, geospace delta B, those will be good places to see the aurora, telluric currents, induction into pipelines, railways, and power grids. That's the past 4 hours Earth magnetic moment from the ground. And a really good way to monitor whether or not you're likely to see the aurora is by monitoring the geoelectric field. So that is the geoelectric field in US and Canada. It's showing actual induction into the grid there. So that is some significant spikes there, all the way up to, up to over 600 millivolts per kilometer there. So that's a great way to see where the aurora are likely. And the reason for those huge variations around the East Coast, that is because of the substrate, because electrical current passes differently through different parts of the crust. So when the crust is made of a different type of material, for example, if the ground below you is made of sandstone, that's very different than if it's made of granite, which is different than if it's made of clay, and that is why you see those big differences there. So, but that's a great one. The empirical geoelectric field data will give you an idea of where the aurora might be likely to be viewed in your location. You can find that on the Space Weather Prediction Center. That's NOAA's website for space weather. So the KP index currently at 5.33. So a little unexpected geomagnetic storm there, and it looks like a coronal hole high-speed stream to me. Correct me if you think I'm wrong. That's not the CME impact yet, so it was just a magnetic field shift, and let's show that next. So here's the solar wind data, and that geomagnetic storm was mainly just caused by this right here, this shift in the vertical component of the magnetic field. So that's that top line there, that is the BZ, the red line. And when we see a strong signal there with a negative BZ, there was a little increase in the density. But besides that, it was mainly just a high-speed diffuse solar wind stream. And that magnetic field shift is what did it. As you can see now in the past few hours, that is now subsiding. The field has weakened a little bit, so we can expect this to drop down to geomagnetic unrest or geomagnetic calm conditions coming soon. The reason it looks like a coronal hole high-speed stream is because over here you can see the solar wind density made it up to about 12.5 protons per cubic centimeter. And then as that dropped down, the solar wind speed came up. So we are still seeing some continued signal there. Solar wind speed here quite quick, 567 kilometers per second quick. And the solar wind density here very, very diffuse at 0.13 protons per cubic centimeter. So that's low enough to suggest an error. Before that, we only saw below 3. So regardless, it is definitely a diffuse but very fast solar wind speed. And again, it looks like the magnetic field is subsiding here, so you can expect geomagnetic storm conditions to end shortly. GOES magnetometers showing some spikes there, and that is sort of the plasma attempting to reach static equilibrium within the outer Van Allen belt. That's where the GOES 16 and GOES 18's geosynchronous near equatorial orbits are located. They're at like 22,000 miles of altitude, and those arc jet moments are them turning on their thrusters, which creates plasma that can affect the magnetometers. And you can expect to see these readings all over the place in the coming couple of days because of the dual coronal mass ejection impacts and the ongoing coronal hole high-speed stream. Next, our top view ecliptic plane field plot, and the South Pole current sheet is now coming back. So that has to do with sunspot degradation, I would suggest. And we may see the South Pole current sheet showing up here as early as sometime tomorrow. I suspect it'll probably be after we make our space weather video tomorrow, but sometime in the next 36 hours or so, you can expect Earth to be snapping into this South Pole-oriented current sheet. So reaching the end of the North Pole current sheet, about to cross this sector boundary crossing, as it is known. Next, solar B field here depicted in blue. That is our line of sight field plot, and that brings us to coronal holes. Again, the current high-speed stream that we see is from a coronal hole. It's got all the proper features of that, and it's probably from these North Pole-oriented coronal holes here now moving into the western limb. That's usually about the position you see when we see high-speed streams associated with those coronal holes. And let's take a look at those from SDO. Bring up the last image here. And there is 211 angstroms for the past 24 hours. So these are all North Pole-oriented coronal holes here. And we could see continued activity. We could even see some interaction with those CMEs. So coronal holes have the ability to amplify or de-amplify a coronal mass ejection. And they can also push it or pull it. So it's very hard to forecast these things, as we don't know what the magnetic field orientation of a CME is. We don't really have enough instruments out there. It's very costly to have instruments in space, because if they're not orbiting one of the Lagrangian points, they've got to use a lot of fuel to stay out there. So anyway, that's the past 24 hours from the SDO 211 angstroms wavelength, the top wavelength, to show coronal holes. And let's move to sunspots. Yeah, sunspots. So that's an important feature, right? And guess what? We've seen a big dip in sunspots. So here's what's going on. And you can expect this number to drop even lower here unless new sunspots suddenly form, which is a thing that can happen. However, at the moment, especially with the setting of sunspot 3413, by far the most active sunspot region, expect a further dip in the sunspot number, and the radial flux can be expected to continue to decline as well. Next, sunspots from SDO. There is SDO Continuum for the past 24 hours. The most likely place for major solar flares remains the northwestern limb. That's this area up here. Sunspot 3413 has been definitely producing some interesting activity indeed. Oh, and one last thing. A new sunspot did form right up here. It is at least a beta-gamma class sunspot group. We'll show high-res imagery of that toward the end of the space weather section. Next, solar energetic particles and solar flares. So we are seeing that SEP, that solar energetic particle event, subsiding. The GOES proton flux here now dipping back below warning levels. You should see those polar radio blackouts ending here as well. We won't worry about that. And you can see this most recent, another rather long duration M-class flare that was about an M3.35 class solar flare. Peak flux was around 7:10 Universal Time this morning on September 2nd. So let's take a look at our favorite wavelengths through which to view solar flares. That would be the 131 angstroms. There's a 24-hour video from SDO in that wavelength. And a great view of that M-class flare, but let's get a little bit closer here. Here's the equatorial view. And again, you might see some action down there in the lower left, but the main action is in the upper right. Fantastic view of that M3.35 class flare in 131 angstroms. Here's an even closer view, and that's going to be pretty spectacular. Yowzers. Dag. Great Earth scale there to show you the size of that arc flash event. Remember, folks, solar flares and coronal mass ejections are separate phenomenon. Solar flares are photons. Coronal mass ejections are protons. So think of a flashlight. If the flashlight was putting out X-rays, that's like a solar flare. Now think of a fan blowing wind. That fan is more like a coronal mass ejection. Solar flares are photons. Coronal mass ejections are protons. Don't get them confused. They are separate events, separate phenomenon. Anyway, moving right along, it's time to take a look at a star chart, because we encourage our viewers to look up. So we like to show a star chart daily. This is skyandtelescope.org. That's the one I like to use. Just press the Now button after putting in your location, and you'll be able to see what's going on above your head. We've got the moon up there, the sometimes fourth brightest object in the sky, Jupiter. It does trade places with Mars for the fourth brightest. And of course, the brightest object here, not so many degrees over the horizon there. The brightest intrinsic object visible from our solar system is up there as well, Deneb. Anyway, here's your solar system forecast. Here's where things are today. And there's where things will be in a week. We will have a crescent waning moon on 9/9/2023. And next, the astronomy picture of the day. So this is the Iris Nebula. And I think it's a great name for it, as it does indeed invoke the iris flower. Great name for that nebula there, the Iris Nebula. And that is a dusty cloud surrounding a bright active star, which you can see in the center of that. That is actually a carbon-rich nebula surrounding that star. The Iris Nebula, today's astronomy picture of the day. apod.nasa.gov if you want to go check that out yourself. Next, coronal mass ejections. And there you can see that one that will be striking Earth later tomorrow at the beginning of this video. And then at the end, you'll see one popping out in the lower left. So the one out of the lower left, that's not earthly directed. The one out of the more extreme one at the beginning, that will have an earthly directed component coming sometime tomorrow evening. Sometime late in the day tomorrow, Universal Time. So here are today's coronagraphs. Those were yesterday, September 1st. Here is today, September 2nd. And oh, check it out, a second event there coming out of the southwestern limb. And before we look at our custom coronagraphs, let's briefly look at LASCO C2 and C3 here. We'll do a quick breakdown. All right, interesting, interesting. Does that have an earthly directed component? I don't think so. So that was at about 8 o'clock this morning. That's 8 o'clock Universal Time. Let's take a look at those in some greater detail here. We're just going to advance these manually for the sake of time. So there's that one coming out of the southwest. I don't think that's earthly directed, but our custom coronagraphs will clarify that. Before we do those, let's take a look at stereo A. And frankly, it's not very good. There's missing data on stereo A. So here come the custom views. They are pretty sweet. So this is another 24-hour video. SDO 193 angstroms, LASCO C2 in red and C3 in blue are coronagraphs. Those are located at Lagrangian point 1, the same place the solar wind is measured. And let's zoom in a little bit closer here to see if we can see the source of that CME from the southwest. And I don't see a source from that. I suspect it is on the far side. So you can see sort of a halo around the entire sun, indicating that there was a massive event on the far side. So that southwestern CME there, not likely to have any earthly directed components. No halo shown on the coronagraphs. So just two headed Earth's way at the moment. Here's 193 angstroms by itself. And let's take a look at filaments. So here's the filament situation at El Teide, Spain. And you can see that there are certainly a lot of filaments indeed on the Earth-facing portion of the solar disk. So there's a first. Let's start from the top. So there's 1, 2, 3, 4, 5, 6, 7, 8. I'll say there's at least 10 filaments on the Earth-facing portion. That is quite a decent number. We'll also show the grayscale imagery to show prominences. Prominences are just filaments that are hanging off the edge of the solar disk. They are the same feature. And let's take a look at filaments by adding (304 angstroms to the 193 angstroms wavelength. So there's another 24-hour video. You can see many snake-like dark absorption features. Those are those plasma filaments we were just talking about. Of course, there is a crown prominence hanging out there up around the North Polar region, right above our Earth scale there. Here's the equatorial view. You'll see more snaky filaments there. Prominences on the eastern limb especially. High likelihood of large solar flares in the northwest. Prominences in the southeast. Prominences at the South Polar region. And that brings us to our GOES 16 SUVI. Yeah, the GOES 16. So here are the past couple of hours from that. You'll see that long duration M-class flare there subsiding up in the northwest. And once again, we still could see additional large flares from up there. So that remains the place to watch, the northwestern limb. And let's blast through our bonus features. First, satellite charging hazards. We have some significant ones here as low-energy electrons build up on the surfaces of satellites right there in Central America, the Caribbean, Gulf of Mexico, and the Eastern Pacific. Those surface charging hazards are going to be moving toward the Central Pacific at the moment. Those could cause some significant satellite communications problems. Probably not any damage to satellites, as internal charging hazards are worse for satellites. However, surface charging can cause some satellite communication issues. Goes electron flux here actually at kind of low levels, and that is sort of a standard feature of coronal hole high-speed streams and CME impacts. When we see a lot of plasma showing up, these readings become erroneous. The GOES 16 and GOES 18 measure the GOES electron flux from their geosynchronous orbits using radiography of the F layer of the ionosphere. There is the 1-year chart to put that in context. Very low levels of electron flux here, about as low as we ever get. And here's the forecast model, expecting an uptick here coming around the arrival time of those coronal mass ejections. So no argument from me there. We are seeing a coronal hole high-speed stream that could subside in the meantime. So we could see an uptick in the electron flux here at the same time as the CME impacts. Next, we'll show the layer where the electron flux is measured. Again, it's at the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation penetration into atmospheric layers, and molecular concentrations. Here is the vibrational frequency of the bridge between Earth and space, the F layer. It's shown daily on the channel. And by the way, if there was an earthly pole flip happening, you would see this looking all jiggy and funky, but you don't, because a pole flip is probably not happening. This isn't even what we would call a significant geomagnetic excursion. So if people who don't understand geophysics are getting you spooked about pole flips, don't unsubscribe from their channel. Keep watching for the comedic value. Because there are some hilarious YouTube channels out there that are disguised as science. So that's the vibrational frequency raw data. Here is the anomaly in megahertz from a 30-day median. And we can expect to see a lot of red on this in the coming couple of days because of geomagnetic storms likely from coronal mass ejection impacts. Those cause the F layer to puff up and become more dense, and as a result vibrate less because there's more material there. The anomaly in megahertz from a 30-day median of the F layer, the bridge between Earth and space. One slice of the thermosphere located at 300 kilometers of altitude. Okay, here's 11:45 universal time for the ionogram raw data. There's 11:45 universal time for the anomalygram, anomaly in megahertz from a 30-day median. Last but not least, we'll show the total electron content forecast. Free electrons from about 12,500 miles down to your ground level. That is your GPS satellite's altitude, approximately. Those free electrons cause signal refraction and can cause GPS errors, which is what you're seeing the most likely things here. And it's actually fairly organized here. So this indicates a likely uptick in the electron flux as well, in my opinion. We typically do see more organized total electron contents when we see higher levels of electron flux. Again, things are quite orderly there, at least on the worldwide basis. Now let's look at the North American total electron content. We're just going to show the anomaly from the 10-day average. So this is literally a count of electrons, and it's the anomaly from the 10-day average electron count. We are seeing some signals here in the Caribbean. So some high electron content signals here. Check it out right in here. Caribbean, Gulf of Mexico, Florida, Texas, Northeast Mexico. There are some high electron content signals. Also Central America, Northern South America, seeing some high electron content signals. We'll play it through one more time, then we'll show you the latest images of the closest star. We'll show you an up-close view of that new sunspot group. So that's what's going on for electron counts. And that new sunspot group looks like it's already degraded. So that was pretty quick. And keep in mind, if a sunspot's not there for at least 12 hours, it will not get a name. So there it is. It is beta gamma class, not beta gamma delta class. Again, the most likely place to see large flares is that setting group in the northwest. And let's continue on to our meteorology segment. So, now again, we don't want you to unsubscribe from YouTube channels that put out constant propaganda and nonsense. Speaking of constant propaganda and nonsense, if you're watching this utter charlatan, this guy cannot forecast his next bowel movement. And if you'd like to leave Ben a comment, tell Mr. Davidson that he ought to submit his textbooks to university literature departments. Why? Because they buy fiction. They buy fiction, Ben, and your textbooks are not science. But don't unsubscribe, because the comedic value is definitely high. Watch the sweating. Watch the anger at his own viewers. We love it. It's absolutely hilarious. Now, one of the idiotic things Ben's been saying is that the Beaufort Gyre is going to release its cold, fresh water into the North Atlantic. Where is it, Ben? Where is it? It's very warm up there. Where's all that cold, fresh water? He's claiming, oh, it's going to shut down. It's going to make the northern hemisphere cold because it's going to shut down the Gulf Stream. Well, where is it then, Ben? You're running out of summer. I mean, we've got 4 feet of new snow on Greenland. Where is it, Ben? Where is it? If you think that guy's doing science, you better look up the definition of the word science. So what we're looking at here are sea surface temperatures and currents. It's actually sea surface temperature anomaly and currents. The water in the North Atlantic is anomalously warm, not anomalously cold. So that's not going to shut down the North Atlantic oscillation. That's going to continue the North Atlantic oscillation as normal. If you're spooked about a year without a summer next year, that is not what you can expect to lead to it. Period. Facts. Deal with them. Deal with them. Our finest days lie ahead. The world is not ending. Deal with it. Sorry, science noobs. These are facts. Now we're looking at surface winds for the eastern world. Here are jet streams for the eastern world. Jet streams for the central world. Surface winds. Surface winds for the Americas. And these are the jet streams. And by the way, if you find Ben's climate nonsense irritating, the only thing more irritating than Ben's climate nonsense is Ben's cosmology nonsense. That is even more pathetic and more ridiculous. It's just the electric universe. Ideas stolen from the electric universe. And I mean, talk about cosmology crap. Ben is full of that. Check it out. New snow on Greenland here. Nearly 4 feet on the southeastern coast of Greenland there. That's just new snow. Melt season is over, people. Look at, obviously there's ice right here, or how would there be snow in the water? Yeah. So yeah, that's new snow from windy.com. And let's take a look at Global Cryosphere Watch here. If you're worried about Greenland melting, it doesn't look very melty. Let's cut back here. How about snow depth? Let's check snow depth, folks, because, again, melt season is about over. Oh, geez, look at Greenland is melting. Yeah, real melted. Okay. It's going to inject fresh water into the Atlantic Ocean and cause a year without a summer in Europe. Really? When? When? It's covered with snow, folks. It's nonsense. Next. Clouds and fog over the Americas. As we zoom in closer and closer to the lower 48 and state facts. Facts, they're very controversial. If you're mad about facts, leave us a comment. However, remember, we don't delete your comments like people like Ben Davidson do. Spends half his day deleting comments and leaving only sycophantic nonsense comments in there. Thank you, Ben. Thank you for fighting the power. Fighting the power of people to understand science. So here's your weather.gov key. And if your location is lit, click your location. We've got flooding occurring in Nevada, Utah, Arizona, and Southern California. Here come some forecasts. That is your GFS 72-hour total accumulated precipitation forecast. Some heavy rains here coming to the Gulf Coast once again. The Florida Panhandle there, going to see an additional few inches of rain there. Here's your 72-hour pressure and precipitation forecast. The same model, the GFS. Next, your temperature anomaly forecast in degrees Celsius. The same model, the 72-hour GFS temperature anomaly forecast in degrees Celsius. Very, very hot temperatures coming to Minnesota and Wisconsin. You'll see 16 degrees C above normal in most significant parts of those states. Meanwhile, California and Nevada, anomalously cold, like 12 degrees below normal in large parts of those states. Blasting right along here. Our jet stream forecast, the 72-hour GFS 250 millibar wind forecast. Lightning mapper, that's the past about 10 hours of lightning. Southern Florida had some heavy lightning there. Shout out to our viewers from Miami. And next, a real-time lightning map. That is lightningmaps.org. Next time you hear thunder, highly recommended. We do have some lightning strikes happening here north of St. Paul. Next time you hear thunder, check out lightningmaps.org and forecast thunder. Tell the natives that you're Zeus or something. Or maybe Thor. That'll be fun. You could pretend to be a horror movie villain with lightningmaps.org. Highly recommended. By the way, if you enjoy the content, consider becoming a member of the Smash Team, as we have a massive operating loss on this channel, and we would prefer to offset that. These videos are brought to you in part by the Smash Team, especially Gold and Silver Smash Team members. We even send out email alerts to Bronze level Smash Team members, so if you want additional content, become a member of the Smash Team. Today's featured product is Forgive, Remember, and Hold Accountable. Because holding a grudge is like ingesting poison and expecting the other person to die. So forgive, remember, and hold accountable. Because forgive and forget is so February of 2020. Don't forget, hold accountable. Because there are certain parties who certainly have been dodging accountability and don't deserve to. They deserve, lifelong prison sentences. You can find links to the Smash Team site, as well as links to all kinds of social media content and so forth at the homepage, smashomash.com. We are still on Patreon. You find links to the Hemp Lucid, the Red Bubble Shop, our Discord chat. If you want to send an instant message, use Discord, smashomash.com, and welcome to the Neo-Renaissance. Here's our Hemp Lucid link, and I'm an endorser of the Hemp Lucid Mushroom Gummies Focus Gummies. I don't have the watermelon flavor, but that is currently available. I have the grape. They both taste fantastic, so check those out. Focus Mushroom Gummies. That's today's featured product from Hemp Lucid. Shop your Hemp Lucid shopping via our link. And help out the channel that way with some tangible items. Some more tangible items here on the list as well. How about the shirt I'm currently wearing? Now, you might think it looks like the wall painting in Frank's office on Scarface. You know, Frank's boss at the beginning of Scarface. It's not. It is similar. I am a collector of Hawaiian shirts, so hit up our Spacewear collection and pick up some products there at amazon.com/shop/smashomash. You can also find other things there like deals on coffee and bulk spices. And we're going to close this mother out with the latest Doppler radar. Some precipitation still striking Alaska there, but we'll be focusing on the lower 48. This is radar.weather.gov, if you're wondering. Recently upgraded this site, and it is a little bit better than it was, so that's pretty sweet. We'll also show clouds and fog, as the remnants of Hurricane Idalia just loiter there east of Bermuda. Here's a water vapor map. And here's your recap. U.S. Doppler radar. Some significant storms there moving west to east across Wisconsin toward Lake Michigan. Here is clouds and fog depicted by the NASA GOES Interactive Weather Satellite Suite Shortwave Radiation Map. And here is water vapor. It shows all the water vapor. When your Doppler is not clear, try the water vapor. And thanks for tuning in here at the Smash News Network, least busted name in news. Once again, congratulations. I realize the channel exists. We remain surprised that you have, with the pathetic, disgusting, putrid, and ridiculous state of censorship on the internet. With all that said, I'm going to head back to the bunker And in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Bunker time. Whoa!